we've got some jobs to do on the wind turbine, and I thought this would be a great opportunity to do a video on our wind turbine. So we've got some basic maintenance tasks to do, which one of them is replace the shaft bearings. There's a problem that's come out from that we're seeing in the field with some of the resin casts failing, and as part of that we're going to do an upgrade on the stator windings, and we're going to replace the inserts on the pitch springs and carry out an inspection, replace any worn components, and then grease the main shaft bearings and the yaw bearings. And we're also going to replace the yaw bearings. This is the turbine that we're going to be doing the maintenance on. Just done some of the tasks. It's been in since 2012, and this is the first time the bearings would have been swapped. So in that time, it's done a considerable amount of work. The core is being swapped because we think there's some issues with it, and they've got a new upgraded one that can give you up to 9 kilowatts, but will pretty much give you the 6 kilowatts, which we never really see that. We're looking to get over 5 kilowatts with it. So hopefully these maintenance tasks will get it running up constantly at around the 6 kilowatt mark, which is what we're after. And then out there's the turbine running in the wind. I'm just going to go over this one again, just to point out what it's trying to show. So the wind hits the back end of the nacelle and pushes towards the blade, so it's backwards on conventional wind turbines. And as the speed increases, the cone, the springs cone in, and that reduces the efficiency of the blade. So that maintains a fixed speed and a fixed output. So a 6 kilowatt should maintain 6 kilowatts of output. The first task is to get the digger up there to take the head off the wind turbine. The chap that's coming to assist me doing the maintenance, he can't get his trailer up there, or he doesn't feel happy about doing any trailer up there, so he just thought we'd do it on the digger. Use the digger as a crane. Feels sensible. I'm not going to show driving the digger up from down there, but where the dumper is, as it comes into shot there, there's the dumper. We've just driven up from there with the digger. There's the digger ready to go, and there's the turbine. Last spins of that core before it gets swapped, and there's a nice picture of it. To jack the turbine, they put this extension bracket on that lives up there, and that gives you a position to jack from with an eyelet. So you have 2 concrete beds. This makes light work of jacking it down. So they have a brake on the shaft. You pull on a cable, and that clamps. It's a disc brake up at the top. It's only used for maintenance, that disc brake. It has no part of the overspeed protection, so that you can stop the turbine and jack it down. We've taken the blades off there, and you can see the brake, and that's the peripheral one, the outer one. That's the magnets that spin around the stator. And there's the head coming off. So the blades are off, the covers are off. And that's now getting driven down with the digger down to load it up onto the trailer. On the trailer, all loaded, ready to go. And there's where the turbine, what we're left with is the gym pole and the lifting bracket. And off he goes for the repairs. So that's the yaw bearing, the yaw roller. The bearing's at the top. We've just seen that, and that's where the roller runs against. That's not actually scored. It just looks worse than ways. You attach this these two brackets on, and they take the stress off the eyelet. That's actually on the gym pole for when you're raising and lowering it. We've got the isolator, the cable, and the earth electrode because it's outside the equipotential zone. And the bolts that would hold the mast up, and obviously the bolts that hold it into the concrete plinth. And then to have something solid that you're going to run your cable over there against, that would be down here on this concrete base. So you can put your jacking point there, and then you can raise and lower your mast with ease. This is the blade now welded up with a plate on it. The fabricator went right through, cut out the bits that were broken, relieved the stress, and then welded these plates on, which makes it quite a solid piece of kit. It's the new bearing, painted shaft, and the other bearing, and the brake there, and that's the new core. The cables to be connected, and that outer thing with the slots in it, that is the permanent magnets, the 12 core. 12 pole permanent magnets that spin past the stator. New yaw bearing. Get the old stator stroke core, and there's some weight in it. You wouldn't want to be carrying it for any length. And it's, oh yeah, it's heavy. So this is the original 6 kilowatt, so the standard, and we've now fitted the enhanced one, but you can see at some stage that the magnets have thrust into the core, and they've worn. And we've also got, I'm not too sure what these are, but I don't think they should be there. And we've got one there, so they could be why we were down on power. I don't think that's right. I didn't see them on the others. So maybe it was, there's a fat chance it could actually have given up at some stage. We were getting some earth faults when it was really, really misty and foggy up here. I don't know, things like that, they're interesting. So it's had a bit of a tough time, and it's done 217,000 kilo hours. So it's a spare because we know it works, but we've got this new one, and hopefully we're going to get the higher outputs out of it. As part of the service, the leading edges of the blades were pitted, so they were resined, and then this expensive tape was put over to make them smooth again, and then to protect them from further pitting and degradation. So that should get a lot longer out the blades and also make it more efficient. These are the springs, so when you get to a certain RPM sort of loading on them, they knuckle and then release out. See, going back together, diggers. Got it on the shaft and we've got it back on. These are the slip rings, and they have so as the turbine head yaws around, the electricity from 3 phases is transmitted, and there's the brushes, so they hit on both sides. The brake, and us getting ready to increase the height with the blades back on. All the covers back on, blades on. The covers are just tie wrapped on, so if you don't maintain it, eventually the tie wraps fail and it stops yawing into the wind, so it's a kind of a safety device that probably wasn't really intended to do that, but it does do that. So if you see one without the covers on and it's not being looked after and it's probably not operational. There's that new tape on them blades. See that engine powered jack makes light work of having to do all this work of lifting it up by hand. You can see that the pulley there pulling the gym pole over, so you're not putting this, you're putting the stress on the beam rather than on the eyelet. You'll be putting a huge amount of stress if you don't have that, and it'll be very fast as well at the point where you need the most precision, and it'll put a lot of stress on the hinge at the base and on the base casting. There's the big power back on, just to get the turbine going again, just on a single inverter. So if it went above 6, they just wouldn't be able to utilise it. Just the metering for the. We'll get nothing at the moment because Tom's got to release the brake. But there we are. We're generating, and we're doing 2,500 watts. Moves around. This is a better meter for it, so about 2.2, 2.4 kilowatts. And there's the turbine. And like an idiot, I left some numbers on the meter that could be used if someone wanted to be malicious, so that's why they're blanked off. As part of the wind turbine upgrade, the wind turbine is an SD, well, would have been an SD6, but the manufacturer changed at some stage. It did start out as proven. So we have got our wind turbine spec there, so it's a Kingspan 6 kilowatt. Permanent magnet generator, nominal 300 volt phase to phase, and that gives out 6 kilowatts. These inverters are the Windy Boy. These are a 6 kilowatt rated inverter. (6,000 watts), and what we've installed is an upgraded stator winding. They call it a core. I think in the generator world would call it a stator, and that's got they call that an SD6 Plus, which means it's designed primarily to give you 6 kilowatts, but it can also give you up to 9 kilowatts in extreme winds. But it means you're always guaranteed to get your 6. What we were finding with the old turbine was I think the core had somehow got damaged or wasn't working correctly, or the magnets weren't spaced right, and we would never ever get to 6 kilowatts. We would struggle to get above 5.2s we might see, and we really need to get above, we want to be sitting about 6 when it's really windy. I don't think that's doing the springs any good on the turbine being stressed. So I think we do need to stress in the turbine on the stator rather than on the mechanical springs pulling it back out of pitch, so you're not getting the efficiency across the blades. I think that's a better way of doing it. Maybe I'm wrong on that, but that feels like the way to go. Because these are only rated at 6 kilowatts and we have the potential to make 9 now, I've got my spare Windy Boy, which is worth having because the SMA don't make these anymore. We do a refurb program, so if one fails you can send it back to them and they'll send you a replacement for about 1,300 quid, which, considering wind turbine inverters are of this kind of standard and quality, are quite rare. I think ABB, might be wrong on the make, the Azorus, that's of a similar wind turbine inverter, but you're not going to get the beauty with these, because we're off grid, is this works with the Sunny Island with the frequency power reduction. So if we generate too much electricity, it knows to back off the power because it ups the site frequency, and then that then brings the power off proportionally. So as part of this upgrade, all these maintenance works on the turbine, that we are just going to bob this on, and I'm only going to, the plan is just to bob it on this bench, wire it into there in parallel with the DC and the AC, and then put in a new curve, a polynomial curve into the settings. I'm only leaving it on the bench like that because the plan is at some stage to move all this next door into another room that's quite damp, so we're trying to make that not damp, but it's a lot cooler, and then we can move all this kit and get this generator that shouldn't really be in here. Like I say, we're off grid, so this generator is used when we haven't got enough electricity. This is a 6 kVA generator. It's got a Perkins engine, 3-cylinder. It's quite a modern thing, but I think it's been re-imported. I think it was manufactured in India, then re-imported, so it might be a complete knockdown from Peterborough. It's gone out to India, been rebuilt in India, then re-exported back into the UK as a cheaper genset. It was here when we bought the property, and it doesn't feel like it's. I don't think it's been professionally done by a proper OEM. I think it's been lashed together for stuff like this. That they wouldn't ship with that. That'd be a nicer finish. And then the exhaust is a bit Heath Robinson, but really it should be outside, because in the summer we have to have the door open. It just gets red hot in here, and that heat, I don't think does any of these inverters any good. But it does do the batteries some good. Which the batteries, I'm going to do a separate video on this, but there's the batteries, and we've got, batteries are here. We've got 24 of them, 2-volt cell lead acid, sort of like fork truck batteries, and they're 2 volts each, so you get 48 volts. Poor cat doesn't know what's going on. And then that'll come back to the fed on the DC cabling. It's a good size. I think they're 200 amp breakers, them 250 amp. Goes into the Sunny Island, and see what's going on with the meters. So at the moment the battery's at 36 degrees. We're putting 40 amps into the batteries, 77% full, and there's a 1.2% error on the state of charge, and that's the voltage it's banging into the batteries, and that's what it is in kilowatts going into the batteries. That's the volts, that's the site frequency. It's moving the frequency because I suspect the wind turbines coming up, all the sun's coming up, and we're getting more from the solar. And eventually, when it hits 51, it's going to go there. You hear that noise coming through. That's the triac inside injecting the electricity, the excess electricity, into the hot water system for domestic hot water use. Not really much more in there. The turbine overall has produced that value. That's 216,542 kilowatt hours. That's since about 2012, so it's 2025. So it's doing a fair bit. For this type of turbine, it is doing a lot more than you would otherwise get from, the guy that comes to service it. He says he's got them. He's been looking after them for 10 years. They haven't got 17,000 kilowatt hours on, and we're doing that every year. Does incur a little bit on the maintenance cost, but that's how it is. Because we're moving this next door, and we're going to make this into do something better with this room, because it's next to that, directly coupled to the house. There's no reason why it can't have a bit of central heating put in and be insulated properly, and we could make it into an office, and then I could move out the other office, get away from my own office rather than be sharing with the wife. And I had the music on full blast. And I just think we've got a room next door that's just being used to store wood, but because it's damp, it doesn't even dry the wood out, so its utility is about as good as a chocolate fire guard. So it's all. I've wired the inverter. I've done the wiring now. So I've just picked up the 230 volts and the DC supply. Put that in the new inverter. I've lashed that up. This is only temporary. So in 5 years' time, that's still called temporary. But the plan is obviously to try and move it next door. I've got the interface lead plugged in, and I'm just loading up the virtual machine, because this is quite an old inverter. So the drivers aren't supported in anything newer than Windows 7. So we're going to run a Windows 7 VM. Now I've powered it up. So this is turning on the 3-phase wild AC from the turbine. I suspect it's going at the moment. Just have a quick. Well, might not be enough on the DC to actually power it. Oh, there we go. So we've got not a great deal of DC, but it is enough to power on the inverter. And then not enough. We're going to struggle setting this up. So there's something there, but it's not great. When they do the testing on the benches, if you need to set these up, they have an old site 110 volt transformer, and they put a bridge rectifier on it, and that gives you 110 volts DC thereabouts, and then you can at least inject the DC. So this is about as exciting as it's going to get until the wind comes up. I think once we're waiting for the wind to come up so we can have some DC to program the inverter, just go over the costs for this maintenance. And this is once every 12 years or 216,000 kilowatt hours, so it's done a considerable amount. So we've got a bit of labour, and then the main bit of the cost is the new stator windings or the core. That was obviously going to be quite a considerable investment. I think the other one probably would have failed within a couple of years anyway, because of them. Looks like the laminate, the casting, the resin casting has pitted. Shaft bearings, yaw bearings, they all need doing. Shot blast, that 425 quid one, that was the works on the front plate that was cracking, which needed replacing, and there's more labour and some bits and pieces. And the last bit's doing the blades, the tape and the pitting, dog sneezing, more labour. It's about £5,000, and then we have to pay the VAT, so it's about £6,000. Right, it's 6,000. But it is what it is. Next time it's probably going to be about £2,000. That's in about 3 years' time. Maybe not even that. We don't need to do the springs. We still need to insert something like 1,500 quid to do the maintenance next time. So I've just done a quick sort of show the calculations, because that £6,000 does seem a lot when you think, well, that's just on a turbine. But if you take it into the 3 years, and we're doing about 17,000 kilowatt hours a year, that's 51,000 over the 3 years. If we were buying that in, which we can't on this site, it would be 25, basing it on 25 pence a kilowatt. Nothing ever worked. 25 pence a kilowatt, that would be 12,750, and I'm hoping we'll get a bit more out of the turbine. So if we just factor in another 1,000 a year, that would be 1,000 kilowatt hours a year. We'd be producing £13,500 worth of electricity, which is more than enough. And if you think about that factor that in, that would pay for the service easy. So to set up the turbine and the two inverters, we're going to need to use the Windyboy setup tool. So I'm just going to quickly show this and then cut it down a bit, because I didn't realise this, I'd completely forgotten. The firmware changed, and we have two types of firmware. One supports the Windyboy setup tool, which allows for the polynomial curve, which gives you the 7 points that you can map. So as the voltage from the turbine goes up, the amount of power that the inverter will try to take out, you can sort of map them 2 points. You can have 6 points. The older version, firmware version, only had a 3 point. So you have your bottom, your zero, your middle, and your top. So you've got no real curve in there. This is why it took me ages to try and figure out why I couldn't connect to it, and it doesn't really help that there's drivers with these old Windows VM machines. There's drivers and other issues. I've done a separate YouTube video on the communication service tool from SMA to talk to it, because it's a bit long in the tooth and old-fashioned. It sort of was designed for the XP era of Windows, and now we're on obviously Windows 11, which is fantastic operating system. So we had loads of little problems, so I'm just going to cut this short and just quickly show the 3 point curve, and then the other inverter, which has the proper firmware, which allows you to have the polynomial curve. This idea of a polynomial curve is just a curve with multiple points on it. I think you just use polynomial just to sound a bit smart. So what I've done, I've swapped onto the other inverter, the one with the newer firmware, so we can get the curve up. The idea is the password is the summation of the date. It's the date on your laptop. The Windyboys don't have a date inside, so, and then you have to have ID 00, capital ID, and then summate the date, and that gives you your password. So got into the Windyboy, and we need to set the settings that we saw that I got off Tom from SWT, Small Wind Turbine Services. And what that does is that will share the burden of the turbine, the power coming out the turbine, across the two inverters rather than just on the one. So each inverter is rated at 6 kilowatts. So that actually gives us 12 kilowatts of capacity. But what we need to do is, if we just run one, obviously we wouldn't get the 9 kilowatts. So we're going to run across the two, and he thinks that running them settings will work. It's a bit of a spanner in the work that we've got this problem with the one of them having the older firmware, so it's only got a 3 point curve. So I might have to do a bit of playing, and the one that's got the bad curve is the one that's on the bench that we've got in temporarily. So what I'll do with that is I may even have him play with it and see, maybe bring that in a bit later, because also I'm a little bit bothered there's an overhead of running two inverters at the same time, because both are trying to make AC from the DC. So that overhead might be 40-50 watts, which, do I really want that on a low wind day when I'm struggling for sun? And I know I'm just eating 40-50 watts just to power another inverter to heat up a room. That's all the heat's going outside. This old software is just painfully slow. It's how long it's taken, at least 3 or 4 minutes to find that, and it's got to pull it back, and put it 1200 board. So that's the curve that we had in, and again this software is really old, so it doesn't show you it gives you these exponent values for the wind that you can adjust, but it's almost missing, like there's a bug in it, because it doesn't bring back the curves even if you program the curves. It's a terrible bit of software, and I'm kind of glad they've moved off it and gone to something else. So I'm now going to type in the values and then write them over. The problem with the wind turbine is it's a little bit like the solar, but slightly different. Whereas the solar, you keep putting power on until your voltage collapses, and then you pull back. So you're looking all the time to the point where you can take power out, but you don't affect the voltage, which we're going to get a lot of sun. You might get good voltage, but low sun, and if you hit it with quite a bit of power, your volt drop will just destroy your power. So you just constantly keep on tracking how much power you're getting with your MPPT. Wind's the same to a degree, but you don't want to slow the turbine down. So you've got to find the power that maintains the speed. And if you put too much power on, the turbine will go too fast, but eventually you will find it is sort of self-correcting in some ways, but there is you do have to just be mindful that if you don't, you put too much, you put a low voltage on and a high power output, you're going to stall the turbine, overload the turbine, which was going to stall it, slow it down, break it, and then you lose your efficiency. So you're not going to be able to keep up your spin. There's a relationship with the two. There's lots of papers written on it. I think it's one of them things you're just going to end up playing with it until you get something that you're half right, half happy with. And I think we're probably going to be the same here. Again, the writing the parameters is painful. I'm going to speed along a bit with this because it's going to take forever. You see now I've got the polynomial curve in, and the values are for the 7 points show at 400 volts we'd be doing 4,600 watts, and really we want to have that in the other one so that both exhibit the same. I'm just playing now, seeing what would happen to the curve. Again, this graph never seems to express itself right. It seems to show at the top you would be then putting down on power, which is not really what you try to express in your curve. I just think the software's buggy. It's something they've thrown together, and then it's never going to get fixed because SMA aren't in the wind turbine inverter market anymore. I'm going to stop again because I'm going to jump onto it, because you need the Windy Boy setup tool to do the newer inverters, and then the older inverter that we've got lay on the bench, that is done on the Sunny data control. So I'm going to jump onto that now. This is the Sunny data control for the older firmware. Again, painfully slow, 1200 baud, and then I always forget it. Every time you open the program up, it opens up in the wrong baud rate. So you've got to go in and you've got to mess about, and then properties. Is it 1200? Yes, put it there. Why it's just not set as default as 1200? I don't know. And then you got to go through this pain again, and it just takes forever. So we've managed to connect. I jumped forward again because you just can't wait forever. We haven't got this. This will not be hours long. So there's the password in. I think it was ID 47 for the date we did it for. And it's going to get the data back. So we're getting the parameters back now, and we need to then go and put these settings in. So this value here is the top end of the curve. So at 400 volts it will do this power output, or it'll attempt to do this power output, and the PID loop will do a little bit of work so that you're not completely a slave to the curve. So I've just written the 4,600 watt. I am speeding ahead a bit here with cutting some of this video down because it's what it does, just to keep you messing about with the scroll bar, is you find the setting you want to change, you write it, then it tends the scroll bar back to the top. And for some reason I'm being incredibly slow at adjusting the settings, but this is I'm going to adjust the wind regulation. So we've got I, we've got P, so these are like proportional gain and integral gain, integral. These are sort of a value that where you're chasing your curve, it will put a bit of intelligence in there, so it's not a slave to the curve. I don't know if you've said that. It's just painfully slow. All the newer equipment, especially from SMA, is all web-based, so you can pretty much do it on your phone. You just jump on the Wi-Fi, jump on a web page, and you're not messing. Whereas this whole having to have software and drivers and then running, okay, it won't let me change that. So Pmax is 4,600, and then we've got to go down and find this curve, this bottom end of the curve. Something that I do whilst I'm in, if I'm ever in, I always check the fans on these. So there's a test function where you can check the fans, because I did have an inverter burn out, and it was the first inverter I'd inherited it. I did not know. I thought that inverter runs very hot, not realising it's running hot because the fan had burnt out, and eventually the inverter failed. And when we got the new ones, the replacement, I was shocked how cool the inverter was. So the fact it's got a fan test function, if you've not heard the fan coming on, you can jump in, run the fan test, and away you go. So I'm setting where it'll start the wind turbine, and this is one I'll probably play with. So at 250 volts coming on the DC, or 251 as I've set it there, so it's slightly, so the other one's set at 250, this is set at 251, I might set this up at 270 or something like that, so that the inverter on the bench doesn't do as much work, which will keep it cooler, because it's not really installed correctly, and then so it'll mean then also then I don't get the problem with too much, with them both being on at the same time at low power when I haven't really got the power to spare. And now I'm setting the points, like the midpoint of the curve. I've just done the value divided by 2 to give me the middle point, so 251 and 400, the midpoint of that. And then I've done the top, so the wind max 400 volt, and then there is another setting for what you want the watts to be at the midpoint. And I think I've gone just halved it, but I think you probably want something slightly different in here. I'll have to have a look. I should really have looked at the curve. I am going to play with this. The more I think about it, the more I'll do it. But we haven't got any high winds at the moment. It's middle of summer, and I actually can't do a lot with electric. So, and there's nothing in the forecast to say we've got any stupid winds coming, because we are going to need quite a bit of wind to see it above 6 kilowatts. And I think that's all the settings done. I think I'll just show you that I do the fan test. Putting the fan test on, and then you should hear the fans come on. So you're at a 1 to do a fan test, and that's the fan test on. And I did hear the fans, and then put it back to 0, and that's the fan test done. And the only other thing, you can't really do remote comms on these old inverters. You can just look at live data, which is, you get this little screen that's about all you've got for live data. So it shows that the DC volts is too low, we need to be above 251 to come on, and that's about as exciting as it gets. It's a bit of a gimmick, but on these, if you hit them, you can scroll through. At the moment we're doing 416 watts, 255 volts, and the other inverter hasn't come on yet, which is what we really want. I made it because it's disconnected, it's doing 45 watts. So the plan is, because this one's sort of lay on its back, that's going to do less than this one. This one's how it is. I've put it on some uni struts just to mount, just to try and let the back plate dissipate heat if it needs to, and just to allow the flow through a bit better. But I'm going to see how it goes. There's not a great deal of wind today. Not a great deal coming for the next couple of weeks, but when we do have a big wind, I'll come in here and just check it's all working and sharing properly. I was going to do go through all the system and a bit more info on the actual turbine and the blades, but I think the video is getting a bit too long, and I think we'll do that on another one. I am going to do a bit about off-grid, which will be water, electric and heating. So I think for this video this will do it. I think we've covered everything from the maintenance on the turbine, the upgrade on the stator core, and changing the settings. Few silly things. Should have asked for permission to do the guy's face, Tom over at SWT, and the registration. That was a bit of a nightmare blocking it out, and I should have covered that personal detail on the meter because that took ages to block out. Thanks for watching, and I'll see you on the next one. Cheers, bye bye.